Hello, this is Frank Days with CorrelSense. On behalf of everyone on the CorrelSense team, as well as all the folks at Red Hat, we'd like to welcome you to today's webinar, Strategies for Securing Availability and Optimizing Application Performance in the Cloud. I'd like to get started by going through the agenda. We're going to open up by talking a little bit about Platform as a Service and its relevance to the enterprise. Then we'll have a little bit of a snapshot of the Openshift platform, which is Red Hat's Platform as a Service offering. Then how Openshift can be used to manage Platform as a Service systems. Then we'll move on a little bit to talking about how we can improve application performance in these environments. Finally, we'll tie it up with a demo of SharePath from CorrelSense and how it can be used in these environments. If there are any questions, we'll go through them at the very, very end. Before we get started, I just wanted to take a moment and go through a couple of housekeeping items. We expect the presentation to last about 45 minutes, and that will include the questions at the end. If you have questions, don't hesitate to take a moment, type it into the chat window in your GoToMeeting setup, and we'll try to do the best we can to get your questions answered at the end. And if we don't handle it at the end, we'll certainly try to make sure your question gets answered by email offline. And finally, we'll be making slides available on the CorrelSense site as well as our SlideShare account tomorrow. Now the speakers for today. First of all, leading things off today will be Vijay Sarathi, who's the Director of Openshift Partner Ecosystem at Red Hat. And then following up that will be Oren Elias, Founder, EVP of Strategy and Business Development at CorrelSense. And now I'd like to hand over the presentation to Vijay.
Thanks, Frank. Happy to be here. Let me start with some context around Platform as a Service, its appropriateness today. And we'll start that by putting ourselves in the shoes of the IT admins today within the enterprise. They face the need to balance the need for agility with the mandate to do more with less. And this is a constant refrain within their organizations today. Business agility is a requirement from their business units, which see a need to develop more web applications, mobile applications, etc., to be relevant in today's fast, rapidly moving market. And at the same time, they're faced with their internal customers within those BUs who because of the consumerization of IT, are putting increasingly more demands on IT. They see what's being done outside, and they'd like to see the same things happening inside. So IT needs to deliver a lot more, and they essentially need to turn IT into a modern manufacturing plant to streamline and accelerate IT service delivery. Okay, so if you look at traditionally how things have been done, with delivering physical or virtual infrastructure, there's a lot of different steps in there. On the physical side, starting with the acquisition of hardware, it can just become a long, drawn-out process that can take literally weeks, and that's just not appropriate in today's fast-paced environment. Even with virtualized environment, this is still something that can, even though things have improved by an order of magnitude, you can get IT ready in hours, probably even shorter if you have the right processes. But still, there's a lot of craft work involved in getting the environment set up for developers. And this is where I think PaaS has become highly relevant and something that enterprises are starting to look at, right? PaaS leverages the automation technologies and the cloud architecture to drive velocity, efficiency, and scalability in IT. So it's as simple as just getting a pre-configured environment for developers now to be able to code their app, push a button, and then deploy it into the cloud environment. So this saves time and money overall. Now, introducing Openshift. Openshift is, for those of you who may not be familiar, is essentially PaaS by Red Hat. It's designed to be a multi-language, self-service platform as PaaS is, with auto-scaling and elasticity capabilities built in. And it fits into the overall Red Hat initiative around cloud and open hybrid cloud, essentially. And we can talk more about that as we go into it, but let me give you a little bit on the genesis of OpenShift and what we've been doing at Red Hat with respect to OpenShift. We started delivering OpenShift to our customers online as OpenShift Online. This service has been running for about 18 plus months and has been seeing tremendous acceptance and adoption from developers worldwide. And even though we've been running it 18 months in developer preview, what hit us was the flood of requests from our enterprise customers, and turned out that a lot of our online customers or developers were enterprise developers masquerading as cloud developers or web developers testing the waters online. And the feedback that came to us was, we'd love to see what you have here online within the enterprise. And with that overwhelming feedback, we basically took that and created or delivered OpenShift Enterprise to customers in December. And this is the first commercial offering that Red Hat has, and is publicly and generally available to our enterprise customers as of December. We've also made whatever we have, technology we have in OpenShift, made that available as open source, and that's the project for that is called OpenShift Origin. So anybody looking to save money, at the expense of time, can go avail themselves of that project and then set up an OpenShift instance on their own. Okay, so just I want to move here quick and hand it over to the Correlsense team so that they can tell you about more of what they do with respect to the strategies and with respect to application performance. But I wanted to give you the context with respect to OpenShift and how it's architected and why it's unique. So OpenShift is entirely based on Red Hat Enterprise Linux. It's the foundation, and it can be configured within the enterprise to run on multiple nodes, with those nodes being managed by a broker, which essentially monitors to see how those nodes are doing and balance workloads, etc. Right? And let's talk a little bit about the terminology. I want to introduce you to certain key terminology within OpenShift. One of them is gears. OpenShift is, OpenShift users interact with OpenShift through these gears. OpenShift gears are essentially super secure, highly efficient containers that host user applications within OpenShift. And to the user, the gear appears like an instance of Grail. They can even SSH into the gear. They can see their processes, the memory, their file systems, etc. But they are prevented from seeing or impacting anyone else's environment on the system overall. And so this isolation of gears is made possible by two technologies. One is called control groups, and then the other one is SC Linux security policies. Control groups are used to carefully control what resources an OpenShift gear is able to consume. Control groups allow gears to consume the CPU, RAM, but also limits the consumption based on configurable policies. The namespaces within allow each gear to have its own file system, complete with system directories, etc. Right? But SC Linux technology, which Red Hat built in conjunction with the NSA, enables some very strict requirements, security requirements. It's essentially a deny everything and allow by exception policy subsystem that ensures that the containers or the gears are very highly secure. But it then enables the multi-tenant environment that is required of a PaaS within the enterprise, right? And so this provides a couple of key benefits. One, the multi-tenancy saves IT admin time because they only have to administer at the node level, not at the individual containers. And it also makes an efficient use of enterprise resources in that it's carving up a single node into multiple instances, right? Okay, so moving on, just very quickly now, if you have that understanding, you can understand now that the developer interacts with Openshift through gears, and they're essentially deploying into their applications at a node level into, or rather into a particular gear. They interact with this from a command line, or they can work on deploying through their IDE. Maybe they have Eclipse or some other IDE that they're using to deploy. When the developer gives the command to create a new application, the broker will look at the nodes, determine the best place to put the application, and creates the gear and provisions the application. Right? That's the whole workflow here. Okay, just real briefly talking about cartridges, as this is relevant to how our partners interact with Openshift or interface with Openshift. The Openshift cartridge technology is an extensible mechanism, right, for providing application development services to developers. So as part of the application creation process, typically the developer comes in and specifies what language they want to program in, what middleware or database services they want to use, and Openshift installs these via the Openshift cartridges, right? That's what the cartridge mechanism is intended to do. This is also the mechanism, by which partners and users can extend Openshift with their own custom cartridges. These cartridges can be, custom languages, data stores, middleware, or other tools that enable the management of the infrastructure, such as Correlsense is going to demonstrate today, that all are able to be brought into the Openshift system, right? So there's a number of Openshift cartridges that are available and listed that can be used as part of Openshift through this mechanism. All right, so just to now put everything together, once the gear that the developer is trying to create is fully configured, the cartridge is installed, the developer begins coding, and typically they can then publish their code and push it via Git, which is a protocol, and once, depending on the framework or the language they're interacting with, once that code is pushed with Git, the application will show up immediately, right, on the container. All right, so in summary, that hopefully gives you a snapshot of how Openshift kind of automates the IT assembly line, right? IT is provisioning multiple gears that are and making them available in self-service fashion to developers. Developers can avail themselves of those resources, create and deploy applications with the push of a button, and this overall simplifies the IT admin task of providing a consistent development environment within the enterprise. So again, recapping here, Openshift is Openshift. So why Openshift, right? Openshift offers three things. One is trust in terms of a reliable, scalable, proven infrastructure that's built on proven technologies from Red Hat, right? And with that, it provides freedom and openness to developers, freedom in terms of choice, right? So developers have a choice in terms of the frameworks, the language, the interface, whether they're trying to program command line, IDE, web console. They have a choice in terms of cloud. They can deploy this within a public, or use it within the public cloud, or avail of this within their own private cloud, or implement some kind of hybrid strategy. And most importantly, they have a choice of scale. With automatic application scaling, they can scale up and scale down the application as and when required. And finally here, openness. Openshift is an open source software stack, so that ensures application portability, that ensures we do not lock in anybody to this platform, and it's extensible. It's extensible in a number of different ways, and this is how our partner ecosystem is being built around this Openshift technology. So there's a number of different partners who are extending Openshift with their own tools, frameworks, cartridges, in order to provide the complementary value and the complementary technologies to Openshift that make sense to developers as well as to the enterprise IT admins who are going to be deploying Openshift or managing Openshift. And so this leads us now to our partner here, Correlsense, who's one of the partners that is has implemented a cartridge and an integration into Openshift and provides some capabilities here to enable IT admins to better manage the application performance within the context of PaaS and Openshift. So with that, I will turn it over to Oren, and who should be able to walk you through that piece. Thank you.
Excellent. Thanks, Vijay. Let me see. Great. So I think there's a lot of great changes that can be done once you start deploying a platform as a service. Vijay mentioned how you move IT into becoming an assembly line, and it opens a lot of new possibilities. With that, though, you start getting new roles and new responsibilities versus the traditional roles within IT. If I take a look at operations on one hand and development on the other end, in the past, there was a clear distinction between developers responsible for the code, maintaining the code, perhaps a DevOps team putting it into production, but then it was very clear IT operations deals with the infrastructure. They'll set up the infrastructure, set up the hardware, set up the operating system, and there was a growing gap and question of who really controls the application platform. So in the past, IT operations had full control and full responsibility of deciding what kind of application server would you use, what kind of database, what kind of middleware, what kind of load balancer. And development essentially had some limited visibility for the architecture, but really no responsibility for maintaining the platform. With the introduction of platform as a service, all of a sudden development have much greater degrees of control, which make the whole IT assembly line much, much more effective. On the other hand, it raises an interesting question of who is now responsible for that middle layer, who is now responsible for that application platform, and where does IT operations start and end as the people who need to maintain this entire platform within the enterprise. So let's take a look at 5 common scenarios of management and see how this transpires into platform as a service. This new challenge of new roles and new responsibilities is both a challenge but also a great opportunity. And it's a great opportunity to have a much more integrated approach to manage these 5 scenarios very efficiently. So the first is user experience monitoring. We can spend a year or 18 months of our lives developing an application. If we're working very agile, it's probably going to be less. And we can spend a lot of time building the platform. But the only thing the user really cares about is the user experience. So for the business user, he could care less about PaaS. PaaS may very well likely be a keyword in professional sports. For him, he wants to know how this is going to help him get his features more quickly, in a higher quality, and in a better user experience. The world has now recognized that uptime is just not enough. You can have service from your online provider, which is 100% uptime, but if you click and you wait for 15 seconds to get a response, that no longer constitutes 100% uptime. So it's all about response times now. And being able to measure response times for every single application being put inside the platform as a service is a key requirement to making sure that the platform is better managed. And we'll see this later on in the demo, exactly how that's done. Second thing that happens is that lines are now blurred between the responsibilities of code and the responsibilities of platform. So in the past, developers were using deep dive diagnostics tools on one end, and IT operations was using infrastructure tools. Our view is that you now have to give IT operations the ability to isolate it down to a line of code so they can work together with development if it's in production. This is an example of a single transaction that was traced through an application put inside Openshift Enterprise, and without any change needed by the developer of the application, the platform now enables you to see full stack traces and full method calls down to a single SQL statement. So if a user calls up and says that something's slow, or if there was an alert that went out, the operations person can now say, well, let me find that specific call, that specific trade that you were trying to perform, and let's isolate it down to database calls, and in this case, method level calls within Java and exceptions, without the need for the developer to do anything special to get there. So the concept we've put together with Red Hat is to bake application management into the platform, where the second you deploy your application and push your code into OpenShift, you will be able to get full visibility down to single lines of code without changing your application. Third use case, classic use case, is where are my cartridges? Where are my gears? OpenShift has an excellent ability to automatically scale up and scale out. When you start getting to many different types of cartridges and 100 gears, you want to be able to understand these dependencies. What we've done is we've taken a look at how can we create better tools to automatically map out the dependencies within the OpenShift topology, so you can really figure out how all these cartridges and gears are working together. Here's an example of using the command line to add a new cartridge. In this case, we took the sample application of Kitchen Sink, and we added in a MySQL 5.1 cartridge, and we attached that to the application. The view that we see here is an auto-generated dependency map that now shows you exactly which gears are talking to which, and in this case can also show the dependency to this new cartridge of MySQL 5.1. We think that when you move from very simple applications into an enterprise scale deployment, being able to get that kind of level of visibility is very, very important to bridge the gap between ops and dev. The next example is what we call preparing to scale. There's a certain limit of how many gears you can put on each OpenShift server, and how to cluster an array of OpenShift clusters together is definitely something that requires understanding of how these gears and applications affect the workload. So as in with every multi-tenant approach, you want to understand how your neighbors are affecting you, and you want to make sure that there's not too many tenants so everyone gets the slice of performance they need. So we want to understand if we have any resource hogs that are taking up 90% of our resources. And we want to make sure that we have enough resource on each OpenShift server so that we can deploy the number of applications that we want. Here's a good example, and what we see here is essentially looking at the entire workload of the machine, but what we really want to see is show us that workload broken down by cartridges. So what kind of workload is assigned to PHP cartridges versus JBoss cartridges? Then take our specific application who's now been scaled on 100 gears and understand which one of these gears is taking more or less of the total workload. So if in the past this was solely the work of a capacity planning tool, historically the capacity planners would be looking at the CPU utilization and I/O utilization. Now that we've moved into a platform, this sits in the middle between the application and operations, and these types of views enable to manage a platform much more efficiently than you could ever manage physical servers in a farm. And last but not least, auto-scaling has always been considered the holy grail. Being able to have an application that can dynamically scale out when you have additional load and then automatically scale down when that peak has been reduced has definitely been considered holy grail within the enterprise. A simple mechanism is looking at it and saying simple heuristics. When we hit 10 concurrent users, spin up another gear. But sometimes that's not enough. We want to be able to take it to the next level and imagine that we could say, if we have a specific application that now needs more workload, even if it's a small number of concurrent users, but just performing heavy load, we can now intelligently scale up. And if we're not meeting our SLAs in a certain component, we'll scale up regardless of how many concurrent users we have to make sure make sure that all the response times are meeting their service levels and we're not exceeding any threshold. So by being able to create a closed loop where you deploy your application, you constantly monitor it. If we now see that response times have degraded on a certain page in a certain cartridge, we can then communicate it back to the platform, automatically scale out 5 additional gears, make sure that the response times are now adequate, and once that peak time is resolved, automatically bring it down so we don't have overutilization. So with this, I wanted to walk through a few examples of what we did with integrating our solution into Openshift. We believe this is a good example of the types of tools that are critical when wanting to achieve success in large-scale enterprise implementations. So we'll take a few of the concepts and use our tool to demonstrate how these work in real life. So just a simple overview. What we have here is we have Openshift Origin Enterprise, and we've deployed a few applications. We've taken the kitchen sink application as an example. And this is an overview of what we have. So we do RHC show. We can see that we have 2 applications, each with a JBoss cartridge and a MySQL cartridge. We set it to do auto scaling, so we have 2 gears currently in each one of these applications. And what we did was we took our technology and baked it into the platform, which means that without any changes to the application, the second you deploy your application into this into our Openshift environment, you get better manageability and complete end-to-end visibility into that app, and this is what we'll see in a second. So what we'll do in the background is we'll launch up JMeter, and we'll run some loads through both of these applications. As you can see, KS1 is the first application, KS2 is the other. We're sending about twice the load into KS1 than we are into KS2. And we'll just let this loop for a while and start generating some traffic on our Openshift application. So with that, I'll switch over into SharePath. And the first thing we'll look at is our application dashboard. So let's take a look at some real-time monitoring. One second while we set it up. Let it run for a bit to gather some more information. Okay, so right now what we're seeing is we're monitoring the KS1 application within the Openshift platform. And what we see here is on the left, on the right-hand side, we see the response times. So without any change to the app, we're measuring every single response time from the end user perspective and from the first time it hit the platform. And we're measuring that and averaging that over the entire app. We can also see some transaction volumes coming in. So we can see which transaction volumes we're meeting versus exceeding the SLA. And then we classify all the requests coming in now through our script into different transaction types. So we'll classify them, and we can distinguish between a login and an index, in this case, a very simple application and a very simple script. What we're doing now is we're seeing this in real time, or near real time, so we're at about a 5-second delay. On the left-hand side, you see the real-time topology, and ties into what we discussed regarding real-time dependencies within the platform. So let's switch over to the topology map and see how is our application behaving. In this case, we see that indeed we've automatically picked up that we have two gears within the JBoss cartridge. We can see the Apache web server, which is essentially also serving as a load balancer. And we can see the MySQL database cartridge that we've added to this application previously. Now, if I take a look at the entire platform, so right now we're looking at a specific application, and now we've switched over to look at the entire platform. So right now we can see that in addition to KS2, it's very easy to now figure out we have another application, KS1, we can see the gears, and we can see the SQL database. So this is invaluable in terms of understanding where is traffic flowing right now. Notice, by the way, that one of these gears in the KS2 has a white line to the MySQL database. Essentially what that means is that it used to receive traffic, but for some reason, probably because we're not sending enough load, there's no communication now being done between that gear and MySQL. This is very useful for tracking configuration issues or gears that are not receiving any traffic, although they should. So the next view that we want to see is, if you recall, the JMeter was sending twice as much traffic than to one application versus the other. So I'll switch over to another view. All this information is being captured in real time. And what we'll do now is we'll take a look at the entire topology, and we'll say, show us this entire Openshift, which may be running 500 different applications. In this case, it's running 2. And show us how is our workload being segmented by these applications. So again, no prior configuration, just the fact that our developers have put in 2 applications into the platform enables us to get this bird's eye view of seeing how our applications are utilizing the resource. Now it's very clear one of them is taking about 70% of the load, and the other is taking a mere 30% of the load. But we can go in further and drill down to see how is the workload broken down within an application between the various gears and between the various nodes. So I'll break it down by node, and essentially what we see now is a complete breakdown by specific gears. This can be filtered out by cartridges. So for example, show us only PHP cartridges or show us only MySQL cartridges. In this case, we see all of them, and then it's very visible if we have one specific gear that perhaps is running background processes and is taking a lot of the resource. We can either separate it out, migrate it, or better architect our solution so that we're using the resource that we have more effectively. The last thing I wanted to show you is how granular this can be done and captured for a developer or a DevOps team. And essentially every single click of the user is now being tracked. So we now have a much better managed platform that can, the second a new application is deployed within Openshift, we can now capture individual user clicks, so a full audit trail of every user action that's been done. So here we see every single click in the KS1 for a very specific time frame. And we can also search only for ones that actually did not complete successfully. So in this case, we see only the ones that actually had errors in them. And we can see the exact response time that was done within KS1 now. It was 10 seconds. And then continue to drill down further and see the complete transaction segment. And complete transaction segment, who is the user, where it was sent, how long did it take, and then as you saw previously, go down to single lines of code to actually isolate it down. So this was a brief overview. The main concept is that the management is now baked into the platform. One of the toughest challenges that we see in getting people to migrate even to virtualization and shared resources is the question that says, how do you guys ensure that I'm going to have control over my own destiny in terms of application response time and availability? In many cases, people say, well, it's much more costly, but I'd rather just have my own hardware. Platform as a service gives you the agility and the self-service, and we believe that this is the main benefit of management, is being able to say, well, put your app on our platform and you will immediately get very, very advanced management and monitoring ranging up from the platform down to the code level. So for the first time, both the ops team and the dev team can really communicate in the same language on the same data set, making the management and monitoring of the platform much, much, much more efficient than you would ever be able to get if you were managing standalone servers on your own hardware. So that wraps up our section of the live demo, and I'll transfer control back. And Tom, Frank, you can take it from there.
Great. So just in summary, to think about the benefits of using this combined Openshift and CorrelSense solution, why, obviously, you can see some of the reasons why OpenShift is your choice for enterprise platform as a service. If you're a current Red Hat customer, you understand the benefits of a trustable and tested platform and the choice and openness that you get by using Red Hat. Why you can actually, in adding CorrelSense to the mix, can really help you manage this platform more effectively with tools that are both readily available and accessible for both operations teams and development teams, providing a common language to manage and understand performance. And having the coverage benefits of not only JBoss, but really supporting all the cartridges that are a part of this platform. I guess on behalf of the team at Red Hat and everyone here at CorrelSense, we thank you for joining us this afternoon. If you're interested in learning more about OpenShift, feel free to visit openshift.com. If you'd like to learn a little bit more about the application monitoring and management solutions provided by CorrelSense, you can visit correlsense.com. We have a great demo at correlsense.com/demo, and obviously you can email us at info@correlsense.com. Thank you and have a great day.